Hey guys, so today we will be making a dogs and cats classifier with keras. So let's just start it. First we will be importing the libraries, numpy, s and p. Now we will be using keras library for the classification. Then we will be importing the model, the layers, and the optimizer from it. Import from keras. We will import from keras dot models. We will import sequential model. Then from the layers, we will import the convolutionary layer. Then we will be importing the max pooling layer, max pooling 2D layer, and then we will be importing a dense layer. Then we would be importing the dropout layer and then flatten layer. Yeah. Now the optimizer. We will be importing the stochastic gradient descent optimizer. Then we would be needing CV2 and OS, and we're done. Now what we will do is we will make a function to load the images, and it will take a folder name path. Then we will make a list in which all the images would be stored, and then for the file in the folder, image is equal to, now CV2 will read the image and give us the pixel values by the function image read, which is imRead, and it takes the path, and we will give it the path os dot path dot join the folder name and then the file name, and we are done. Now what we need to do is first we will check if there is an image or not. If image is not none, then we could get the images dot append the image, and we also need to resize it. We have different sizes of images, and to put it in a machine learning model we need to just have a fixed size. Let it be 100 for now. 100 by 100 image we will take, so we will just resize it with cv2 dot resize the image, and we need one more bracket, and we need to specify that to what size we need to reshape it or resize it, and now we are done. And now we will just return the images list of images, and now we are done. And now we will load the images, and first the cats data is equal to load images, and similarly for the dogs. And now we need to just fill in the path cat's path, dog's path, and we're done. Now wait, I need to assign these variables is equal to and done. Similarly for the dogs also, we will do it for the dogs. And we are done. Now what we need to do is make a class of an animal so we can handle the data easily. Class animal. Oh, now it will take in the data and the label which we want to assign it, and then we will just say self dot images is the data and the label self. And now we need to make targets, so I'll just write a function with which will take in the labels and give us the output as a targets, all our targets. So I will directly write targets is equal to self dot make targets. We will write this function now, make targets with this lib, and now we will just write the function def make targets, and it will take in the label, and then it will just say that one target for one image is this, and its label index is equal to 1. And now we could just return and return an array of targets uh, which has a length of the images, length of self dot images. Self dot images, and now we are done. And now we will just make our animals. Cats is equal to an animal with the cats data and the label be 0, and for dogs it is uh, it is also an animal with dogs data, and its label would be 1, and we are done. And now we need to concat our training data and its labels so that we could just train on it. So let's just write a function. We will write a function so that if I make an animals list of cats and dogs, then I would be able to write xs comma ys is equal to concat animals. Now we will write the function def concat. It will take an array of animals, or list you can say. So first we will make xs in which all our training data will go, and ys in which our labels will go, or we can say targets. Now for animal animal in the array, we and for the image in animal dot images access dot append the image. And similarly for the labels also, for target in animal dot targets ys dot append the target, and we are done. And now we need to return it. We need to return an np array because the keras library takes an np array as an input. So let's just convert it into an np array. So we will return, and we also need to normalize our image, and it ranges from 0 to 255 all the values, and so we will just divide it by 255 to get a normalized array. np dot we will divide np dot array of access comma by 255, and we will also return np dot array of the targets, and we are done. And now we just need to construct a model. Model is equal to sequential. Now we will add layers to it. First the convolutionary, then the max pooling, and this pattern of convolutionary and then max pooling goes for 3 layers, and then we add dense layer. So conv 2D layer, kernel size of 3 by 3, filters maybe 8 filters, and then the activation function, which is relu. And then for the first layer we also need to add the input shapes. So first we will add it later. First we will just add all the layers. Max pooling 2D layer, which will just say pool size of 2 by 2. Yeah. Now we just need to copy it. We will just change the filters, the amount of filters, 1 and 2. We have 3 of these layers. One layer having the convolution max pooling, then convolution max pooling, then convolution max pooling, and we'll just change the number of filters, 16 and then 32. And now we will just add the input shape. And it would be we have a 100 by 100 image, so 100 comma 100, and it's an RGBA image, RGB image. So we have 3 channels, so we will just write 3 with it and save, and done. And now we will just add the dropout layer, the dense layer, flatten layer, all these things. So model.add dropout layer, 0.2 chances of dropping out, and then percent of dropping out. Then we will just flatten our model, Yeah, and now we will just add dense layers. Dense layer with maybe 50 units, and then 25, and then we need just I'm doing this for gradual change. If we just jump too high, it would not be good for the model. Maybe 5, and then we just need to classify two things, so we will just add 2 units to the last layer, and with an activation of sigmoid, which is a probability distribution activation function. So we could just write activation is equal to sigmoid. Yeah, now we're done. And now we will just compile the model. Our learning rate, uh, no, first we will just make an optimizer. SGT is equal to an stochastic gradient optimizer with a learning rate of LR learning rate of 0.01. This is a standard learning rate I'm using. You can use it whatever you want. So there's a problem. Activation keyword argument, unexpected keyword argument. Oh, I need to put this thing here. I just need to delete this, and now we're done. And we have made an optimizer, and now we will just compile it. Model dot compile with this optimizer, or we could just simply say SGD, and loss is equal to, we will use categorical cross entropy, and maybe I don't know its spelling. Oh wait, what's the problem here? What's the problem? No value for kernel size. Okay. Wait. Maybe I have added one more E to it, and maybe now it's okay. So now I need to I just should just check its spelling. 1 minute, just 1 minute. Categorical cross entropy. CATE, and here's the spelling. And now we are done. We need a here, and now we're done. And now we just need to train it. Model.fit for the excess data with bias labels, with epochs. I'll just do one epoch. You can train it for several, but for now, just for showing you, I'm doing it for one epoch only. And we will shuffle it. True. And batch size, that would be 100. And now we are done. So we will just quickly train it. new terminal. We will just say Python 3 classifier.py. And it's training. Oh, there was a problem. Not a tuple. Okay, so I need to change it to an list, and this should be done for each and every of them. So 1 minute, just 1 minute. And from here, put it here, delete it from here, put this, command plus save, and done. Maybe we are done. I'll just run it again. Python 3 classifier.py, and maybe oh, new style, get arg format, but argument is not a tuple. Oh, we need a tuple in there. Where is it? We need a tuple in there. This is for this one. We need one more. Yeah, now we are done. Then this should also be a tuple. Wait. It would ask this also to be a tuple. Where is it asking here? Oh, up here. Here it's asking me to give it a tuple. Yeah, now we are done. I'll just copy this. And now maybe it works. And yeah, it started training. So yeah, it started training. So thank you guys for watching this video, and please tell me uh, that what you think about it, and please leave a like and subscribe. And yeah, it's just training. Then I'll stop the video. And yeah, so thank you guys for watching it, and please subscribe, like. Thank you. I'm shutting down.